Hi. So in this video, we are going to look into something called Poiseuille's formula. What exactly is about? So Poiseuille, the person who had investigated the flow of liquids through something called capillary tubes. I know that this is the first time, if I'm not wrong, if you are hearing in this course, okay? If you have heard and if you are aware of this word, then it's good, well and good. So basically, capillary tube is nothing but a transparent tube, which is whose diameter, okay, it will be in the cylindrical shape, whose diameter is very small. Diameter is very small and open at both ends. And open at both ends. So such tubes we call it as capillary tubes. So he had observed and investigated, conducted experiments on this and obtained a formula which we are calling it as Poiseuille's formula. His formula is related to the volume of liquid, okay, flowing out per second through a capillary tube which is having certain length and radius, which in terms of diameter, under a pressure difference. So we can write the Poiseuille's formula, and that Poiseuille's formula we denote it with Q. We denote it with Q. What exactly it tells? It tells you about the volume of the liquid flowing per second. So this is what actual formula. This is not actual formula, that according to the definition. He made certain assumptions, okay, while obtaining this. Let us look into those assumptions. What are those? Then we can look into the expression. First of all, the flow, whichever the flow of liquid is happening here, it is streamlined. So you can say that it is less than critical velocity also. And other than that, whatever the capillary tube you are choosing, it is horizontal, so that the gravity doesn't affect there. And I'm sorry, the pressure is constant over any cross section of the tube. So pressure is also constant across any cross section you choose. And of course, the last one, whatever may be the liquid layer which is in touch with the wall of the tube, that is going to be at rest. So I can say that bottom layer of the liquid, bottom layer of the liquid, which is in contact with, which is in contact with the wall of the tube, is at rest. These are the assumptions which he made to obtain this formula. So let us look into its derivation, but this is a simple one, like, because we are going to use what to say, we are going to use dimensional analysis to obtain this equation as of Poiseuille's formula. So derivation for Poiseuille's formula using dimensional analysis. Say that you have a liquid which is flowing steadily through a capillary tube, and the volume of the liquid. So Poiseuille's formula Q, what it says? It says that the volume of the liquid, V refers to volume here. Okay. If it is velocity, I will denote it like this. Okay. If it is volume, I will write completely. Okay. So it says that the volume of the liquid flowing out per second through a capillary tube. This is what the Poiseuille's formula tells us. So his observations are like this. Whatever the volume of the liquid flowing per second, whichever he observed, these are depends on few things. What are those? So he observed that in this particular Q is depending on the coefficient of viscosity. What is the representation for coefficient of viscosity? Do you remember? I hope you will be able to write on your own. Please write down that. And radius of the tube, which I will denote it with R. Then something called pressure gradient. What is this pressure gradient? It's nothing but pressure upon length. how the pressure is changing with respect to pressure gradient. So I denote it with P upon L. So what he observed that all these things are depending, or Q, which is volume of liquid flowing in per second, is depending on this. So let us write eta, it is depending. It is depending on the radius of the tube. It is also depending on pressure upon length, which is a pressure gradient, which we don't know how exactly the formula is. So according to the dimensional analysis, what we'll do, we will take n power a, I hope you remember, r power b, p by l whole power c, because you know the dimensions, that's why I'm writing like this. Now we need to assess the values of a, b, c, right? So if you take out this constant, say that you are taking out the constant. So we're taking out the proportionality, so we'll write it as q is equals to small k eta a r power b p by l c. Okay. So where here k is dimensionless constant. So we need to write down the dimensions of each quantities. So let us start from LHS side. Let us start from LHS. This is our main equation now. Okay, we need to find out the values of ABs. Okay, now if we start from LHS, what is that LHS? LHS and similarly RHS. If you observe, say that LHS, if you see, we have Q. What is Q? Q is nothing but volume upon time. Q is nothing but volume upon time, isn't it? So volume I can express in terms of LQ, right? And time as T. So LQ upon T. Don't forget the brackets because we are writing the dimensions. Let it take time, no worry. So L3 T power minus. Now, similarly, K is a constant, don't write. Write for coefficient of viscosity, write for R, write for P by L. Let me see. Write along with me instead of watching this, pause it and write down. So let me start with P by L. So P by L whole raised to C. What is P? Pressure upon length. So pressure, you know, force upon area. How will you write force upon area? M, L, T are the common. T power minus 2, because it is force, MLT power minus 2 upon area. So by L square, so it should become L power minus 1. This is for pressure, whatever I have written, power C upon length power C. So if we correct it, so we'll be able to say that so M power C, L power C, if it comes up, it becomes L power minus C. This is already minus C. So L power minus 2C, T power minus 2C. This is RHS side, one by one I'm writing. What about R? Similarly, can I write here only R? I hope you won't get confused. This is R power B. What is R? It's radius, which is nothing but length. Length power B. Now the last one, coefficient of viscosity. That I'm not going to explain you how to write, because you have already written the dimensions. So please write down the dimensions of coefficient of viscosity, which I'm directly writing, but you better do how exactly you got this. So dimensions are M L power minus 1 T power minus 1 whole raised to here. So these are RHS quantities, right? This is LHS quantities. Now substitute them one by one. So substituting all these things in the given obtained equation, so you get L cube T power minus 1 is, this is a right hand side, LHS, sorry, RHS. Then you have a constant, something called K, which is no constant, so it doesn't affect any much. So you can write K if you want to. I don't mind writing. So let us write down K on this side. So eta raised to a, so m l minus 1 p minus 1 a. Similarly, r raised to b, that is l power p. The next one is p by l, which we have done it as, what is this? Then it has p by l as mc. We have written directly, but it's write down, then later we can write. M l power minus 2 p power minus 2 whole power c. If you assess it, like if you multiply inside, so you can write it as m a l power minus a t power minus a l power b m c l power minus 2c t power minus 2c. Please look, try to follow me. If not, please stop and go back, look again. Because the k value is 1, don't worry about that. So all m's you can write. So if you observe, it is m power a plus c. Similarly for l power minus a plus b minus 2c. How about t? T power minus a minus 2c. Look at the left hand side. There is no m, so I will write m0 l cube t power minus 1. The k is nothing but 1. Don't worry about the k. Now on comparing the equations with respect to the same dimensions, you can write m power 0 is equals to m power a plus c. Similarly, l cube is equals to, can we write l power minus a plus b minus 2c. Similarly, t power minus 1 can be written as t power minus. I'm comparing both the sides. Therefore, you can write a plus c is equals to 0. That is, a is equals to minus. That is one thing. The next thing here, if you observe, it is, okay, let us start from here only. 3 is equals to minus a plus b minus 2c. Already you have written for a, so substitute a value, whereas minus c, so it becomes plus b minus 2c equals to, very correct, b minus c is equals to 3. Then similarly here minus 1 is equals to minus a minus 2c. If we can write 1 is equals to a plus 2c, or else simply substitute the a value here, which is already minus c. So minus 1 is equals to c minus 2c. Therefore, minus c is equals to minus 1. Therefore, you got the c value as 1. And since you got the c value as 1, now substitute c value here so that you get b value. What is the b value? Therefore, c value is 1. So b minus c, which will become b is equals to 2. Since you got b, you have already observed this. What is a then? A becomes, since a got c is equals to 1, a becomes minus 1. Be careful here. Now if you just look, a value is minus 1, b is, I hope you're able to see, minus 1, 2, 1. Now just look back, just to go back. This is what the expression we have written. Q is equals to k eta power a. Substitute the values of a, b, c here. If you substitute those values, wait, just a second, mistakes on the calculation. C is fine, A is fine, B I lost. Actually, see, this is minus C. Okay, minus 1. If it goes there, it becomes 4. That's also very insane thing. B minus 1, 4, C is equals to 1. Now by substituting all these values in Q, so Q is equals to K. A value is minus 1. The next one is B value 4. P by L value is 1. So we can rewrite this expression as K P R power 4 upon L times eta. Right? P R power 4 eta L. The value of K is found to be, because this is a dimensionless constant, but we don't have the value, through experiments, the value of K is found to be pi by 8. So pi by 8 eta L, this is the formula which we call it as Poiseuille's formula, which gives you an idea about the amount of liquid or the volume of the what to say, the volume of the liquid flows per second. So this, I'm not sure about the spelling, but it's formula. Okay, it's also numerical related to this in the next session. I hope this becomes very easy. So I'll stop.